Hello everyone, this is Vamsi from EC final year from Gayatri College, Visakhapatnam. Today I am here to discuss about design and verification of dual port RAM using System Verilog. Dual port RAM is a random access memory that allows multiple read or write operations occurs at same time. It is a memory which consists of two sets of address signals called as write address and read address, two types of data signals called as write data and read data, and two types of control signals as read enable and write enable. Here the clock signal is used for synchronizing both read and write operations. Reset is used to clear the previously available content in the memory. The write enable, write address and write data are the signals corresponding to the write operation, and the read enable, read address and read data are signals corresponding to read operation. And coming to dual port RAM, compared to single port RAM, it has both read and write operations can be takes place at the same time. If in a particular address, if a particular data is kept in that address, and at the same time, and at the same address, if you want to read the operation, the previous data available in that particular address will come into the output. Coming to the test bench architecture, we has different classes called as transaction class, generator class, driver class and monitor, and interface which is used to connect driver with DUT and monitor with DUT, and these all the components are enclosed in the environment. This environment is enclosed in the top module, etc. Coming to design, I will explain in the environment. Coming to design part, here I has declared all the signals, that means clock, reset, enable, write enable, read enable, and write address, write data and read data. And the clock, reset, enable, write enable or read enable, which I has represented as WR and RD, these are the input signals, and read address and write address are also input signals. That means 4 down to 0 I had specified here. That means in 2 power 4 16 locations we can store our data. Here the W data which is writing the address, the data into that particular address are 7 down to 0. That means in every location we will store 8 bit of data. Here I had specified R data as an output reg type, and I had, and for memory specifications I had used the reg 7 down to 0, memo 15 down to 0. That means in 8 the data which is of 8 bit has to be stored in 16 locations. That means in 16 different locations, 8 bit of, in each location 8 bit of data is stored. And always I had written here logic as, for in every postage of the clock, if reset is equals to 0, the data in each locations, that is in 0 to 15 locations, in all 16 locations the data has to be by default X, don't care conditions. Else if the reset is equals to 1 means, and enable is equals to 1 means, it will check for read 1 and write 0. That means we have to do write operations. In order to do write operation, the available data at the write data pin has to be moved to the write address specified location in memory. If read is equals to 1 and write is equals to 0, then the data available at the read address location has to be moved to the output, that is read data. Otherwise, if read is equals to 1 and write is equals to 1, both read and write operations has to be takes place. So first we have to write the data. The data at the write data pin is moved to the write address in the memory, and that and for read operations, the data available at the read address specified memory location has to move to the output, that is R data. If read and write is equals to write is equals to 0 and read is equals to 0, the memory content should not be changed. In 16th locations also the memory location has to be itself only, it does not change, it has to be same. So I had used mem of I less than or equals to mem of I. Okay, coming to transaction class. In transaction class we will specify all the input and output signals, and we will specify the uh, rand keyword to address that particular signals has to be randomized using in generator class. So here we are writing all the signals, that means write data. I am specifying enable is equals to logic high to run this to run the code in the enable, if enable is equals to 1 only. So I am specifying write read and write address, read address and r data. While I am specifying a W address, I need to pass on up to 16 addresses only, from 0 to 16 locations only. So I had used constant here. In transaction class we will specify function void. In order to don't return any value, we are using void here. In display function we are passing an argument called string, because from various functions like generator, driver and monitor we will pass a string to know the status of the particular input and output signals. Here I am specifying the percentage yes and percentage 0t for knowing the execution time in that particular class. Here read, write address, read data, read address and read data, and enable are the signals to be displayed when particular display function is called from various classes. Coming to generator class, in generator class we are creating a handle for transaction class as tx, and we are declaring a mailbox as zen2drv, and we are creating a logic port down to 0 w underscore address for using in this particular write, read and write read tasks. We are using here function new and a new constraint to allocate memory for mailbox. So in this in this we are using the mailbox zen2drv to assign this data to this particular mailbox. I had used different task blocks for write, read and read write. Okay, coming to write block, I have to repeat it once. We have to create an object for handle created here tx, and we have to randomize the data. Otherwise we will comment it. We will give write is equals to 1 and read is equals to 0. That means write operation has to be takes place. In write operation the address at the w address has to be assigned to the w address. Handles the write address has to be assigned to write address which I had specified here, and then this write address has to be put in the mailbox in gen2drv. As I am using randomization function, the randomized data at the transaction class is moving to the w address here. After that we have to read the data available in that particular write address. So I had using here repeat one and creating an object as for trans tx handle, and here I am giving write is equals to 0 and is equals to 1, and for reading that particular location we have to assign that write address to the read address before getting the data. So after getting the read address we will put this data into the generate2drv mailbox, and for displaying this function we are using tx.display, which will go to this transaction class display function. And read write operation we have to do first write operation and then read operation, otherwise we will get the default values for that data type. In repeat block I had created a new object for tx handle. While randomizing I am getting write is equals to 1 and read is equals to 0, and then I am at the same time I am giving the write address to the w address, and putting this data into the mailbox and displaying the status of this signals. After 10 seconds we have to repeat that we have to read the data, then write is equals to 0 and read is equals to 1, read is equals to 1. Then this write address has to move to the read address, and then data has to be put on the mailbox. Okay. Coming to driver, in order to take the data from the mailbox, we are creating a handle for mailbox gen to trv, and creating a handle for transaction class. In this virtual function used because in which because the driver is dynamic in nature and interface in classic in static in nature. In order to make a communication, we had using a virtual interface in between them. So we are declaring the virtual interface as VIF. So here I had created an interface with INTF name. Here interface INTF, as it is a sequential circuit, we have to pass this clock and reset as an arguments to this interface block, and the remaining all signals has to be specified as a logic in the interface block. Coming to driver, in function u, here I need to pass on the data. I need to pass on the data from driver to the interface by using virtual interface. So I need to pass on arguments as virtual interface and the mailbox. So here using generator to driver mailbox and virtual interface to assign to this particular declarations. In task run, I had used gen2drv.get. So in order to get the randomized signals, the randomized stimulus from the generator to driver, I am using mailbox get function, get method. So as driver is converting this packet level data coming from the generator, which is randomized into the pin level data, we have to specify as this all the input signals as enable, write, read, w address, read address and write data. So in order to get the status of these signals, we are using tx.display and transaction display function. In monitor, we are using another mailbox because we are putting the randomized signals into the interface. Through interface, it is going to the DUT, and in DUT it will do the required functionality operation and gets output. This output has to be moved to the monitor by using another virtual interface, because the same virtual interface, because the monitor is dynamic in nature and interface is static in nature. In order to communicate between these two, we are using virtual interface. Here again a virtual interface INTF is specified with VIF, and the transaction handle is created as TX in order to display the function. Okay, and then mailbox is I declared as mon to scoreboard, because I am getting the data from here to monitor to scoreboard. I am creating a mailbox of monitor to scoreboard here, and after that in function you have to pass the mon to scoreboard and virtual interface, and this data has to be assigned to this mon to SCB and virtual interface here. After that, in order to in task block, in order to get the data from the virtual interface through virtual interface, we are creating a new object, and in repeat one we are getting the virtual interface data into the TX and write data and write enable, read enable, write address, read address, and read data also, because we in DUT the operation is done, and that output signal has to be come to the monitor part. In order to check the status of the monitor, we are using tx.display, and then it is kept to mon to SCP scoreboard, because to this data has to move to the scoreboard for the test pass or fail purpose. In scoreboard I am creating a extra handle tx.reference for checking the whether the functionality has obtained the required outputs. So in my I am creating mailbox mbx. In function u I have to pass a mailbox called mount to scoreboard, because the virtual interface has no does not takes place here, so I need to only specify the mailbox only. So the data available in the mount to scoreboard is moved to the mbx mailbox. In task run we are repeating only once the data. That means mbx.get means the data which is kept in a monitor, kept, kept to the mailbox in the monitor, has to move to the scoreboard here and display the scoreboard content, whether the data is received perfectly or not. Here in tx dot, in order to check for required functionality, I am using an object. I am creating an object tx underscore reference. So the data available in the monitor which is on txs, tx dot enable tx dot read tx dot read write address write data has to be moved to the tx underscore reference. I am using only here inputs. The r underscore data is an output. So I am moving inputs to tx underscore reference. In if else block or in case statements, we will specify, we will create a model and check for the required output, and we will check the actual block and actual output and expected output, because the actual output which is come for a design is under the transaction class, and the expected output is coming at the tx underscore reference in the scoreboard. If both are same, then the test is pass. If both are different, test is failed. Here I did not mention about the test fail or pass conditions. So in environment, in class environment, we will specify all these blocks. We will in environment we will specify all the scoreboard, monitor, driver, generator, and transactions. So in order to create handles for all the generator, driver, monitor, and scoreboard, we will using gen, drv, monitor, and scb. In order to specify handle and create an object, we will use mailbox and new function here in both in line 7 and 8, and creating a virtual interface also, because the virtual interface is also a part of environment only. In function u, the virtual interface has to be passed, because in test bench we are creating intf physical interface clock and reset, and this is passed to the env is equals to new function. In new function we have to specify pif. This pif is comes to here, and this virtual interface this is assigned to vif. In generator we need to specify only mailbox. In driver we need to specify only mailbox and the virtual interface. Again in monitor we have to specify mailbox and virtual interface. Again in scoreboard we have to specify only mailbox. In task run, first I have to run the task for write operations. So I had used gen dot write and remaining as declared as run functions. In generator I had first created write operations tasks. So in driver I had used run, and in monitor I had used run tasks. So and in scoreboard also I had used run task run only. So in environment I had first generating the gen dot rate and drive dot run, monitor dot run, scoreboard dot run. After some time I have some delay, I have to read the data which is written in that particular address. So I am reading gen dot read and driver, monitor, and scoreboard as run. After some time, first I need to specify the read rate operation. So in order to do read rate operation in generator class, I had declared as gen dot read underscore rate, this one, and driver, monitor, and scoreboard. After that I need to get the after in read rate operation I had used two blocks, that is here it is first here it is reading, but it is writing, and then it is reading. So in order to get the required data I had using delays, and again I am running the driver, monitor, and scoreboards. Coming to test bench, we have to include all these components in the test bench, as these all are under the test bench top module. So we have to include all this environment, monitor, driver, generator, transaction class, and interface also. had included, and in module top we had created an environment handle and clock and reset as bits. In always block I have in every 5 seconds I have to change the state of the clock. In initial and final block I had used for the reset condition, because I had taken here reset is active low reset, that is reset is equals to 0, the active condition is high, is satisfied. So in first I am keeping reset is equals to 0. After that, after some time, after the negative edge of the clock, I had given reset is equals to 1, and finish simulation time as dollar finish as 1000. So I am instantiated that this design part into the test bench part like this. In initial block I had given environment has a new function with a passing an argument of PIF. After that passing we have to run this complete tasks in the run part. So here using in initial begin block I had used $dump files to get the waveforms. Okay, we will run the code. In first generator writing the data, when write is equals to 1, we are randomizing only these things. In task write block I had commented this one, remove this one and run it. Here in generator I am just randomizing the W data and W address, so when write is equals to 1, W address is getting B. In B address we are storing the D data. As it is it is moved to the driver, the same data will be appeared, and I am giving enable is equals to 1 all the time. In the transaction class it is getting once all the time, and in monitor also the same data will be repeated, because we did not started read operation till here. We'll starting reading operation. The write address to be assigned to the read address, then the B will be displayed, but the read data will obtain after the monitor, because the DUT is doing the functionality of given inputs from the driver, and will move the output to the monitor only. So we did not get output of the driver, we will get the output only at the monitor and then scoreboard. So in monitor block we are getting in B address we are getting D data, and the same pass on to the scoreboard using mount scoreboard mailbox. After that we are doing read write operation. So in order to move to read write operation we have to first write the data. So while randomizing, here we getting in address 3 we are storing the C4 data in the address 3. So this is same thing will be moved to the driver, and then collector, and then scoreboard. So after read operation we are reading the data. While reading the data the same address will be passed to the read address, but the data will not become. So after moving the same data will be moved to the driver. After monitor only we will get the data. So in read address 3 the data C4 is getting, and here the data D is obtaining, which is previous data, because I had used R data as reg type. A register is it will store the data, previous data, until the new data will occur. So here I am getting R data as D. So when the new data is obtained at that collector, it will change at a third location, and the C4 data is obtaining. We will check in the waveform also. Here when reset is equals to 1, enable is equals to 1 completely. When write is equals to 1, in address B we are storing data D. After that, when write is equals to 0 and read is equals to 1, we are getting the address. In address B, we are getting the same data as D. After that, we have to perform reset operation. That means we have to first write the data. So I am keeping logic high for some time. So 1 and 0, when write is equals to 1, in address 3 we are keeping the data C4. After some time, we are doing write is equals to 0 and is equals to 1, read is equals to 1. Then in address 3 the data will be come at C4. So as the data will come after the next clock, the data will take some time. So until here. So for getting proper output at the console window, at this console window I had given a delay at the environment as hash 10, hash 20 and hash 20 for these operations. In every fork join block I had used hash 50 for delay for doing first write operation, then read operation, and then read write operations in this environment block. Thank you.